This lesson of polynomial functions and the characteristics is specifically going to discuss the x and y intercepts. We've already talked a little bit about x-intercepts and their multiplicity in a previous lesson, so we're just going to expand upon that in this one. So our x-intercepts, again, where the graph crosses the x-axis, those are also called roots, solutions, and zeros. If we ask for a zero, we want it to be written as an ordered pair with the x value, comma 0. The y value of any x-intercept is always going to be equal to 0, which is why we call them zeros. Okay. We do have those multiplicities of x-intercepts. We learned about them in a previous lesson. So it's where the graph will cross the x-axis more than one time. So you can see the little shape that occurs from it to help you determine, is it a multiplicity of 2 or multiplicity of 3. You can also use a graphing calculator or use Desmos.com to graph a function so that you can determine its multiplicities. And finally, you can also determine multiplicities from the factored form of an equation. So our y-intercepts, that's where our graph is going to cross the y-axis. They're always written as an ordered pair with 0, comma, the y value. And the x value of all of our y-intercepts is always going to be 0. Okay, so it's always going to be 0 for the x and some other number for the y. You can only ever have one y-intercept for any given function. It's never going to cross twice on that y-axis because then it would not be considered a function. It's kind of repeat of stuff we've already know. Okay, first couple of examples. We need to determine the x and y-intercepts, as well as determine any multiplicity for an x-intercept. So our first example on the left-hand side, you'll see that we have an x-intercept over here at the -1, and we have another x-intercept at 3. Each of them pass through once, so they have no multiplicity. So the x-intercepts would be -1, 0, and 3, 0. We do have a y-intercept. It crosses the y-axis at y equaling 3, so that would be the ordered pair 0, 3. Okay, good job. Our next graph does have x-intercepts with multiplicities. We have an x-intercept at -3. This one does a bounce, so that's a multiplicity of 2. We have an x-intercept at +1. It also does that little bouncy curve. So we have a multiplicity of 2 is there, and we have x equaling 2 as the final x-intercept with no multiplicity. So they're -3, 0, multiplicity of 2, 1, 0 with a multiplicity of 2, and 2, 0. The y-intercept, where do we cross the y-axis? That y value is -20, so its intercept is written as, oh, it's actually a little bit above that, excuse me, about -18 actually. So our y-intercept will be at 0, comma, -18. Couple more graphs. Check these guys. So the x-intercept of the graph on the left, the first one what we see is at -2. It does that squiggle shape, that cubic function shape, so that's a multiplicity of 3. And then we also cross through the x-axis one time at x equaling 1. So those are your two x-intercepts, -2, 0 with a multiplicity of 3 and 1, 0. We do have a y-intercept. It crosses the y-axis at y equaling 8, so that intercept is 0, 8. And this last graph that we have on the right-hand side has 1, 2, 3 x-intercepts. At -2, 0, it does a bounce, so it has a multiplicity of 2. At 2, 0, no multiplicity, and at 4, 0. We do have a y-intercept. It's somewhere between 30 and 35, so I'm going to say that that's probably about 32. There's a way that we can find it if we have the equation, or we could use the x-intercepts as well to help us determine those, but our y-intercept for this one is 0, 32. All right, moving along. We have a graphing calculator cheat sheet. So if you were using the TI 83 or 84, whether it's the colored version or not, doesn't matter. This is in your unit packet. It's also in our online resources. We have a class set as well that we're going to be able to use in class. If you don't have a graphing calculator at home, you can also use desmos.com to do the same information that we're looking at today. So using our graphing calculator, we are first going to type the function into the calculator. So back to our steps. So our steps are going to be press y equals, type in your function right here, x squared plus 2x. After you do that, I'd like for you to hit the window button, and you're going to change your window to match what you have in your notes. So we have a blank graph from -5 to 3 for the x's, minimum and maximum, and then -2 to 8 for the y's, so change that window. After you've fixed your window, then you can press graph and you will see this shape. It is a quadratic function. It does have 2 x-intercepts, and one of those x-intercepts is at 0, 0, the origin. The other one is at -2, 0. Neither of them have a multiplicity. You guys, if you ever have the origin as an x-intercept, that will also be your y-intercept. So that's kind of a gimme. You got an x-intercept to 0, 0, you got the y-intercept to 0, 0 as well. Great job with that. All right, let's scooch on, try another one. Okay, we have another function, k of x equals -x cubed minus x squared plus 5x minus 3. And in this example, you'll go back to y equals, type in that entire function. Press pause for a second so you can do that. Okay, now that you're back, you can then check your window. So press the window button, change the x minimum to match what we have in our given graph at -5. Our x max to be 4, the y minimum to be -12, and the y maximum to be 6. Okay, that will zoom in so that you will see this particular graph. We see that it crosses the x-axis at -3 and at +1. And you'll notice I do have a little goof here. The multiplicity is not at the -3. It's actually at the x-intercept of 1, 0. So that's a typo on my part. Forgive me. Sorry about that little goof. So those are the 2 x-intercepts. One of them has a multiplicity, the other one does not. And our y-intercept occurs at 0, -3. And I'm going to make a quick connection. If you are in standard form, it's not factored. The last number added to the very back end of your equation is always going to be the y value of your y-intercept. It'll tell you exactly where to cross. Okay, so there's kind of another gimme so that you don't even have to look at the graph. You can go, oh, y-intercept -3, 0, -3. Cool. All right, let's try a few more. Here we go. All right, our next example, w of x. This is a big one. It might take a minute to type in. That's okay, take your time. Again, if you're using desmos.com, you can do the same thing here. You don't really have to change the window though, because you can do that by just zooming in and out with your mouse or your fingers. So w of x is -x to the 5th minus 2x to the 4th plus 8x cubed plus 16x squared minus 16x minus 32. Wow, that is a big one. So this one can have, remember that fundamental theorem of algebra, we can have up to 5 different roots, 5 different places it crosses the x-axis. Let's check and see. So change your window for your x's to go from -4 to +4. Change your y values to go from -40 to +10. And you'll notice in this case, we're also changing the scale. We're going to count by 5s because we've got such a big value, big range for the y values for the range. After you get all that in and you press graph, you will see your x-intercepts occurring at -2, 0 and +2, 0. At -2, 0, there's a multiplicity of 3. It does that funky little squiggle cubic shape. At x equaling 2 or 2, 0, we have a bounce, so that's a multiplicity of 2. And again, our y value, you can look at the constant at the end of the equation to give us the y-intercept at 0, -32. We could also estimate, but if you're in standard form, just go ahead and take that constant value. All right, here we go. One more. H of x. This is our last example for x and y intercepts. Press y equals, type your function into the calculator. Check the window, make it match the given graph that you have, -4 to +3 for the x's, -5 to +5 for the y's. Don't change your scaling, make sure that you're counting by 1, so the scale for each of these should still stay 1 or be changed back to 1. And then when we press graph, we're not going to see exact x-intercepts. I actually used Desmos to help me with this one. You can also use the trace function, and we'll go over this in class. I'll try to do another video of how to do that so you guys can see this a little bit better. So our y-intercept, that's the easy one. You can see that clearly. It crosses at -1. That's that constant value at the back end of our equation. I do see a really good x-intercept at -1, 0. And the other two x-intercepts, they're close to -2 and close to +1. And if we use the trace option, or we actually determine the x-intercepts using the calculator or using Desmos, we'll get -1.6180 for the x-intercept to the farthest left, and 0.618, 0 for the x-intercept on the farthest right. Great job with this lesson. Again, I'll try to do an additional lesson to show you guys the steps on how to do things in the graphing calculator, and make sure that you practice some of the problems on worksheet F. Have a great day, guys.